We're going to talk internal resistance. Every battery has internal resistance. It's the amount that the battery pushes back from moving electricity from the chemistry inside to your device. Now, this is an important aspect to understand about your batteries because if you're building something like this, a multi-battery pack, your weakest link is the biggest problem. See, if this guy right here, for example, had a really high internal resistance, well, then when I run this thing, it's going to be like striking a match across the box. Just heat, fire, explosions, and then you get something called cascade runaway, where that one explodes, heats up, the ones around it heat up, they explode, and eventually the entire pack, boom, up in flames. In your devices, you're also going to notice that it says, don't mix brands. That's because they can't guarantee that brand A and brand B both have the same internal resistance, and the one with the most resistance is going to create the most heat. Batteries also create more resistance as they become more dead. The more charged a battery is, the less resistance it's going to show. So let's compare some of the batteries. I'm really excited to see what the Paleblue has to offer because we're not actually measuring the internal resistance of the chemistry. We're measuring the internal resistance of the circuit that controls the chemistry. So let's give this a try. We're going to start off with one of the more common batteries out there, and that is nickel metal hydride. I have with me my internal resistance meter, and this thing measures the internal resistance of the battery. So we're just going to turn this on. There we go. Let's start with nickel metal hydride. Okay, so it's around 16.25 milliohms. Next, we're going to measure the internal resistance of a lithium-ion battery. Now, this is the chemistry that's used inside of the Paleblue battery. Now, this one is 39.1 milliohms, which is higher. This is also an older cell and it's a used cell, so it's probably just worn down. Now let's try the Paleblue USB-C rechargeable D-cell battery. This battery is supposed to mimic an alkaline battery. So let's see what resistance we're getting. Now, my guess is we're going to see a very low resistance and it's going to spike, and I'll explain why in a second. So it's about 7.6 milliohms, which is really low. Now that's an important number because that means that this doesn't kick back as much when you're trying to use it. It means less heat, means less resistance. Don't mix this with other cells unless they're Paleblue. But the Paleblue batteries have an interesting advantage where that the battery itself is producing 3.7 volts, and so it can actually mimic a much lower internal resistance than other batteries have. One of the great things about this is if you have a light, the light is going to be bright instantly. If you have motors, it's going to be able to supply that amperage right away. It's not going to have that delay that you're going to see with other cells. So internal resistance is important when you're picking out a battery. And the Paleblue seems to shine when comparing it to other batteries. So if you're looking at a battery to run your devices and you need it to be reliable, charge quickly, and conveniently, the Paleblue battery is definitely the choice you need to go with.